Yeah, Assalamualaikum. Today we will be doing experiment for buoyancy. So the objective for the experiment to calculate the metacentric height by using the buoyancy floating strategy. And my name is ALISA, with the reading number metric 2013-32036.
My name is AHMAD ZIKRI ZAMRI. My metric number is 2016-2006.
My name is AHMAD NAZIRUL, BA1 AHMAD MAWARDI. My metric number 2013-32994.
My name is ALISA. Metric number is 20133-2034. Now we will start our experiment. The first procedure is do a center line that goes through the center hole of the pontoon to the 0° angle. So here we already draw a line here, and then fill the red container with water to float the pontoon on the water. Make sure the water is enough. Here is the water. Okay. Next, we place the adjustable weight to the second bottom row, which is 135 mm away from the base. Here. Center. And next, we ensure the plumb weight is pointing the zero reading on the angular scale. Okay. And then we start our experiment by adjustable weight move in a step across the width of the pontoon. First, we take the reading 135 mm of height. First, we move a step left side to the apparatus. Make sure the pontoon is not moving. Then the ice is perpendicular to the scale. -10 mm is 2. Then we move the second plate is -20 mm to the left hand side of the pontoon, and we get the angle is 4 degree of angle. And then we move again to one step of left hand. Make sure the pontoon is not moving, and then the data is 6 degree. So we move again to the left hand. We get the degree is 8 angle. For -50 we get 10 degree angle. Then for -60 we get 12 degree of angle. Next, we move to the right hand side. First, right hand side of 10 mm. We get 2 degree. For 20 mm right hand side, we get 4 degree. For 30 mm right hand side, we get 6 degree. For 40 mm right hand side, we get 8 degree. For 50 mm right hand side, we get 10 degree. For 60 mm right hand side, we get 12 degree. For 70 mm right hand side, we get 14 degree. And then that's all for my part. I will pass to my member.
Okay, then after that, so we move the wood to 200. Wood in center. Then make sure the plumber is 0 degrees. Also make sure the plumber at 0 angle. Then we take the reading. So for the 0 angle degree, we get a 0 angle degree. Then we move to left side. So for the negative 10 angle, we get a 2 degree. And then we move left side. Make sure number is stable. Then for the next 20 angle degree, we get a 4 degree. Then we move again. So for the negative 30 angle degree, we get a 6 degree. Then we move aside. So for the negative 40 angle degree, we get a 9 degree. Then we move. So for the negative 50 angle degree, we get a 11. Then for the last one, take the reading, then we get 12 degree. Okay, next, take reading for the right side. Okay. So for the 10 angle degree, we get 2 degree. Then the reading we get for 20 is 2. Sorry, we get 4. Then we move to the next one. Then for the 30 angle degree, we get 6 degree. 6, then we move. Okay. Then for the 40 angle degree, we get 8 degree. Okay, next, no more. Thank you, that's all for my part.
Okay, next we move to 265 mm. And we adjust the vegetable to meat. Okay. After that we assume to 0. Okay. And then we go to the right first. Okay. Okay, one more. The angle is 4 degree. Okay, at 30 last. The angle is 6 degree. We go to negative 10. Okay, the angle is 2 degree. We go to negative 20. Okay, the angle is 4 degree. We go to the next last negative 50. The angle is 6. Okay, that's all.
Okay, for the last step, we change the weight to 315. Okay, then measure the angle is 0. Then we move to the left side first, which is negative 10 millimeter. And then we set the angle. So make sure that it didn't move. The angle is 3 dp. And then move to the left side, which is 20, negative 20. The angle is show 6 degree. And last to the left side, which is negative 50 millimeter. And the angle show 10 degree. 9 degree. Okay, that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Yusri bin Mohamed Yusoff. My metric number is 2013320007. The effect of moving weight on the floating body will affect the stability of the body. This is because when the weight is away from the center body, the body tend to tilt to the weight. The body tend to tilt to the weight direction due to the weight is unbalanced for the body. From this experiment, this evidence has shown when we move the weight to the left and right, the angle will increase when the weight is far away from the center of body. Hence, moving weight on the floating body will affect the center gravity of body. At last, greater the distant weight, distant weight from center body, lower. Greater the distant weight from center body, lower the stability of the body. That's all from me. Thank you.
The importance to determine the stability of a floating body. We know the stability will be found to depend on the position of the center of gravity, and in particular, it is positioned in relation to the center of buoyancy. This leads to a definition of the metacentric height as a measure of stability. So, the importance to determine the stability of a floating body is do the experiment buoyancy and then calculate the metacentric height by using the buoyancy floating study. We know metacentric height is a parameter to measure the static stability floating body, as it is defined as a distance between the center of gravity and of a body, and it is metacentric. It has a direct relationship with the stability of the body. Then the effect of height on the floating stability, where it is large, the metacentric height, so it is more the stability. While for the weight is the weight of the floating body acts vertically downwards through its center of gravity, and this is balanced by an equal and opposite buoyancy force acting upwards through the center of buoyancy, which lies at the center of gravity of the liquid displaced by the ponton.